Hello, and again, welcome back. Here's an interesting question on integration for 5 marks. Given this integral here, with limits 4q and q, 5x times root of x dx is equal to 15,066. Find the value of the constant q. Well, first you need to establish, I'm not sure if that's the right word, but we need to know or establish that, I'm going to use that anyway, what we got. X root x, x times the root of x is equal to, and you're just going to make it into powers, is equal to x to the power of a half. X times x to the power of a half. Which is equal to, which of course is equal to x to the power of 3 over 2. And let's do one for x squared root x. X squared root x is equal to, well, that's going to give us x squared times x to the half. And that is equal to the power, x to the power of 5 over 2. We're using the integral x to the power n dx, which is of course equal to x to the n plus 1 over n plus 1. And of course plus c, your arbitrary constant. And n of course is not equal to minus 1. Now, using integration, and so we write it out here, and we use I, is equal to, well, what's our question? With limits for q and q, and that's what we need to find. And it's 5x times the root of x dx, times the root of x dx. And of course, we can now write that as the integral sign 4q with limits 4q and q, and 5x to the power of 3 over 2. 5x to the power of 3 over 2, because x times the root of x is x to the power of 3 over 2, which is what we had written here. And now we can put that into with our limits. So I've got 5 multiplied by x to the power of, because it's n plus 1, 5 over 2, and divided by n plus 1, which is 5 over 2. And with our limits, because remember, it's 3 over 2 plus 1. So 3 over 2 plus 1 is 5 over 2. So, and that's with our limits for q and q. Oops, it doesn't look like a q, does it? So it's all in real time, so let's change that to make it look like 4q. Yeah, that's good to go. And now we just tidy up that. So let's just extend the page. And what do we have? We have 2x to the 5 over 2. That is equal to 2x to the 5 over 2 to the 5 over 2. And again with our limits of 4q and q. 4q and q. And that gives us 2x squared times the root of x. So that gives us 2x squared times the root of x, again with our limits for step by step, 4q and q. You can miss some of these steps out, but as a teacher I'm just showing you exactly what I'm doing. And that's of course going to be equal to now, well, we write out what the limits work out to. So that's 2 multiplied by 4q, substitute it in, 2 multiplied by 4q all squared, 4q all squared, and times the root of 4q. And then we're going to subtract with our q substitution. So minus 2q squared, 2q squared, and times the root of q, times the root of q. And extend our page. And what does that give us? That's going to give us 64q squared. That's going to give us 64q squared root of times the root of q, times the root of q, minus 2q squared, minus 2q squared times the root of q. So have everything now. Now just tidy up. That gives us what? 64q squared minus 2q squared. That gives me 62q squared times the root of q. 62q squared times the root of q. Now going back to the question, 15066. So I've got to sub that in. So 15066 is equal to what we just found. So we're going to write 62q squared q. So therefore 62q squared times the root of q must be equal to 15,066. If that's the case, then we can solve nicely. So I've got q squared and times q to the half times q to the half is equal to 15,066 divided by 62. That gives me 2 and a half. That gives me 5 q to the 5 over 2. Yep. So that gives me q to the 5 over q to the 5 over 2. Q to the 5 over 2 is equal to 243. That's good because that tells me that q then, because I can just reverse that, is 243 to the 2 over 5. And therefore q is equal to 9. And that's it for how many marks? 5 marks. For 5 marks, there you go.